Hey Pete, I hear you got a new dog. Show us your new dog. Who's this?
It's Chewy.
Hi, Chewy. Chewy was rescued from the pound in Gridley after a 5-week stay and has turned out to be a fantastic family companion. Push the edit button, Chewy, push the edit button. Gather around the old laptop, children, with your poor old dear papa. You heard it here first, I think. Wait for it, wait for it.
50,000 down through that canyon that some of us call Croyle Canyon.
Croyle Canyon.
So, first that kind of bothered me, but the sheriff said it was okay, so I was like, okay. And so, but between
There it
those
is, it's
two,
official. The sheriff said so.
That's where the water went this year.
Right, yeah.
It's Thursday, the 15th of June. Time for an Oroville update in the mighty Luscombe. Clear. So this is the Thursday, 15 June flyover with a lake level about 812 feet, just below the gates to the spillway. Inflows are pretty well matched to outflows at only about 5,000 CFS. We'll take a closer look at this spillway inlet now that the water's nearly out of it and why it was such a crucial piece of the puzzle during the emergency. The bottom of those spillway gates is about 813 feet. Operators during the emergency couldn't operate the spillway at a slow flow for fear of head-cutting erosion on the busted end of the spillway. At the same time, operators couldn't operate the spillway at high flow down low levels like 813 feet for fear of scouring this inlet to this spillway, because it's not concrete, it's just gravel or rock, riprap. So operators were forced to operate in a yo-yo effect, shutting off the gates at about 830 feet, and turning them on at about 850 feet, and operating between 50 and 100,000 CFS. And there's no talk of improving this inlet, and there really isn't a need to. If the spillway is fixed, then you can slowly lower the gates and ease the flow as you bring the level down closer to 813 feet without fear of scouring the inlet to the spillway. Coming up next on the boat ramp parking lot is the concrete batch plant for the structural concrete plant. The structural concrete plant is going to be that concrete that's used for the actual spillway itself, which will be heavily reinforced with steel rebar, reinforcing bar. And we won't see this plant going probably until August, because first they got to build up the base using RCC roller compacted concrete. More on all that later. A little closer look at the structural concrete plant. Now let's take a closer look at what's going on in the emergency spillway, that OG wall from the right side of the spillway gates to the edge of the boat ramp parking lot, where you can still see the white bags of rock that were helicoptered in at great expense during the emergency, where crews are preparing access for one of the most interesting engineering feats, the Secant cutoff wall to the emergency spillway. Here's the basic design concept for the emergency spillway. The original OG weir shown in red here, remember it was the fear of this weir failing last February that caused the evacuation of 200,000 people due to erosion, is to remain in place and be reinforced by a roller compacted concrete buttress and RCC splash pad, all anchored in place by the Secant cutoff wall buried deep into bedrock. And as of the media conference last week, engineers were still deciding exactly where to place the Secant cutoff wall, how far down below the emergency spillway, and how deep into the bedrock, based on the latest geological reports. So what the heck is a Secant cutoff wall? Let's check out this video from piling contractors in Australia.
Secant pile walls are used to construct in-ground retaining walls. Because these piles are cut into each other, they form a continuous wall, which can reduce water inflow into the excavation in front of the wall, as well as retaining the soil behind the wall. Secant piles can be constructed using board cast in place, or continuous flight auger methods, cased or conventional CFA. First, a shallow guide wall has to be built. This guide wall is shaped to locate the piles to tight tolerances, ensuring that the overcut from one pile into another is as required by the wall design. The guide wall is constructed from reinforced concrete. Often polystyrene or timber void formers are used to obtain the scalloped shape of the inner face of the guide walls. Once the guide wall has developed sufficient strength, the piles are constructed through it. The wall can be made from alternating soft and hard piles, in which case the soft pile is usually unreinforced, or from alternating full-strength piles, in which case both male and female piles may be reinforced. First, the preliminary or female piles are drilled to the required depth. Generally, these piles are constructed in a hit-and-miss sequence in order to ensure that adjacent piles are not damaged by drilling nearby until the low-strength concrete is set. After allowing sufficient curing time, the remaining preliminary piles are constructed. Careful attention must be given to the concrete mix used in the preliminary piles to ensure that it has sufficient strength when the secondary piles are cut into it, but gains strength after that with continued curing. Once sufficient preliminary piles have been constructed, the secondary or male piles are then drilled between adjacent preliminary piles. The secondary pile is cut into or secanted into the two preliminary piles either side of it. By careful control of the verticality tolerance when drilling, it's ensured that the overlap between preliminary and secondary piles remains intact down to the underside of the deepest excavation level. Subsequent secondary piles are then constructed, forming a continuous retaining wall.
So since the secondary piles are secanted into the primary piles as opposed to tangential or just parked right next to them, it makes for a very robust design. Also that we will never again see this level of erosion anywhere near the emergency spillway ever again, if it's ever used again. So I guess my next question is, what happens to all that material that was already laid down in front of the emergency spillway? Does that come out and get replaced with new RCC? Well, it looks like our once scenic and beautiful Croyle Canyon is looking less like a beautiful scenic canyon and more like a construction site. Crews are blasting and digging deep into solid bedrock, well past the weathered bedrock, to make sure this spillway never moves again. This is DWR footage from just 2 days ago, 13 June. And it's official, the Dragon's Teeth stay, the diversion blocks at the bottom of the spillway, they're just going to be patched up. Bill Croyle had some interesting stats that at 100,000 CFS, that water descending from the bottom of them gates to the bottom of the spillway is producing 1 million horsepower. Here you can see crews digging much deeper than the original design, solid bedrock. And these temporary dirt roads, of course, will be removed in the spillway. So once the bedrock is excavated to a desired level, the dental work begins, where they clean everything out with high-pressure water and then begin pouring. Check out the size of this pumping truck here. They pump dental concrete. Dental concrete is generally unreinforced concrete poured into all the cracks and crevices in an effort to build up a base level enough that you can begin the RCC, the roller compacted concrete process, because that process requires vehicles. It's laid on much like asphalt. And this concrete that we're seeing poured here is actually coming from off-site from Matthews Ready Mix in Oroville, California. So here you can see the dental concrete beginning to level things up. Here in a couple days, the roller compacted concrete process should begin in earnest on or about the 19th of June. Here you can see crews washing down the bedrock, and it looks like they've done a special rip on this bedrock to give it an extra notchy finish to give the dental concrete a good bite, something to bite into. You can kind of see the rip marks there, that extra aggressive finish on the bedrock. The deepest hole they have to fill here, the plunge pool, is over 150 feet deep. It's going to take a mountain of material to fill that hole. Right here at the bottom of the screen, you can see this area being prepared for more blasting. Another question I'm going to have at the next media conference call is, with the Croyle Canyon blowing out the south side of the spillway, how do you build that back up without forcing yourself into a giant retaining wall kind of situation? Or does the RCC just pile up on itself to provide ample support for the new spillway? Down here on the lower landing is the batch plant for the RCC plant, the roller compacted concrete plant, and of course all this will be conveyed by truck. And it looks like they already got the crushed rock operation going on the right. Back on the upper spillway, looks like they're nipping it back another 600 feet so that there is just 1,000 feet of the original upper spillway remaining for this season. The remaining 1,000 feet of original upper spillway up to the spillway gates will be replaced next summer. Meanwhile, crews are removing and replacing the original caulking in the upper spillway, which apparently had some level of toxicity, thus the hazmat suits. So as you can see, Croyle Canyon is all but filled in with access roads, and as per the plan, those access roads are going to have to be cleaned out before next winter, because Croyle Canyon is going to be the extra overflow for the new lower spillway for next season, which begs the question of why they decided to use trucks instead of conveyor belts for this operation. So the next media conference call will be next Wednesday, the 21st of June, and I'll be asking these questions and a lot more, and your questions too. Hopefully the engineers from Kiewit will be there. And let's take one more wide swing below the spillway and show you what looks like the new power lines that are going in for the Hyatt power plant bypassing the emergency spillway. Right down there on the bottom of the screen. Bunch of new towers going up. So stay tuned to the biggest engineering project in America today, and certainly the one with the tightest time constraints. Thank you for your continued support of this channel and all your great and constructive comments. $12 gallons, just about $50.